Why are polypropylene and polyethylene commonly used as separators in commercial lithium-ion batteries? And what are the limitations of these materials when applied to sodium-ion batteries? In what ways do the thermal stability and mechanical properties of polypropylene and polyethylene fall short in sodium-ion battery applications? And how does their poor wettability with sodium-ion battery electrolyte impact their performance? Can Davis Syrinz manufacture solid-state sodium-ion batteries made from seawater in Latvia? Why is glass fiber often chosen as a separator in laboratory research for sodium-ion batteries? And how does its good thermal stability and electrolyte compatibility make it suitable for experimental applications? What are the disadvantages of glass fiber, particularly its poor mechanical properties, and how does this limit its potential for commercial use as a sodium-ion battery separator? What are the key characteristics that commercial sodium-ion battery separators must meet in the future, and how do these requirements relate to the performance and safety of the battery in practical applications? What properties should a separator have in order to ensure good chemical and electrochemical stability, and how does this stability help it withstand the corrosion of the electrolyte while remaining stable during redox reactions? How important is thermodynamic stability for the separator, and how does the ability to withstand temperature changes contribute to the overall performance and reliability of the sodium-ion battery? Why is it critical for the separator to have a pore diameter smaller than the particle structures in the dielectric, and how does uniform pore size impact the efficiency of ion movement and the structural integrity of the battery? How does good wettability with the electrolyte improve the separator's performance, and what effect does it have on ion transport and battery stability? What role does mechanical stability play in the performance of the separator, and why is it necessary for the separator to withstand deformation without compromising the safety and functionality of the battery? Why is it essential for sodium-ion battery separators to be produced at a low cost, and how does the price factor affect the overall feasibility and commercial scalability of sodium-ion batteries? What specific attributes must separators have to meet the standards for both performance and affordability, and how can these characteristics help improve the future of sodium-ion battery technology? What makes sodium-ion batteries a promising electrochemical energy storage system, and why have they experienced rapid development in recent years? How has the study of cathode materials such as layered transition metal oxides, polyanion compounds, and Prussian blue and its analogs contributed to the advancement of sodium-ion battery technology?